I hope you've had the chance to look over the vocabulary words in your textbook. Now we're going to talk about all of these new words. The probability is the chance of an event occurring. Now wait a minute, what's an event? I'm going to come down here. An event consists of a set of outcomes for a probability experiment. But wait, what's a probability experiment? A chance process that leads to well-defined results called outcomes. And we saw that word outcomes before. An outcome is a result of a single trial of a probability experiment. The sample space is the set of all possible outcomes of a probability experiment. Okay, that's a lot of words. Let's put this in some context. Let's say that our probability experiment is going to be rolling a 6-sided die. So a little cube with dots all around it numbered 1 through 6. We're going to roll that die and see what we land on. The sample space for rolling that die would be the numbers 1 through 6. All the possible outcomes. We put it in these curly braces because that's what a set is in mathematics. We put it in curly braces to indicate that it is a set, a collection that goes together. An outcome would be one of those rolls. So if we were actually rolling our die and we got 4, we don't look at the side of the die, silly me. We look at the top of the die when we roll it. So if we were to roll a die and get a 4 on top, that would be an outcome. One outcome, one result. The probability, the chance of an event occurring, it depends on the event. So with rolling a die, we could have an event that is roll a 3. And the probability of rolling a 3 would be 1 out of 6. I'm going to make this a little bit bigger. So the probability of rolling a 3 would be 1 out of 6. I have 6 outcomes, and 3 is one of those 6. But what if my event is roll an even number? Well, with an even number, I have 3 of those out of the total 6. Or if I reduce that fraction, my probability is 1/2. So an event could be one outcome, one single outcome, or it can consist of multiple simple events. So we call each one of these in the sample space a simple event because it is only one, but we can create events that are more. Which leads us to the next definitions of a simple event and a compound event. So going back to our definitions, a simple event, an event with only one outcome. This would be like roll a 3. A compound event is an event with more than one outcome, which could be roll an even number. It could also be roll a 1 or a 2. I have 2 outcomes there. Okay. So hopefully the example of rolling a die helps clarify a lot of these definitions, and we'll continue to show these definitions in the next few examples. The last 3 definitions that we'll be looking at before we talk about more examples deal with the 3 different types of probability. So even though we have one definition of probability, we actually have 3 different ways to determine probability, and it will depend on the structure of the probability experiment and what we are using to find that probability. So the classical or theoretical probability is what we've been doing. Theoretical probability uses sample spaces to calculate the probabilities. And so the formula for a classical probability, the probability of an event E occurring, is going to be the number of outcomes in the event E And I'm using the hashtag symbol as number because it also represents number or pound or sharp, depending on the context that you use it in. In math, it means number, so we're going to use it for number. Number of outcomes in the event divided by the total number of outcomes in the sample space. So this is what we've been doing with the die. So rolling the die, sample space, rolling the die, sample space is 1 through 6. The probability of an even number rolled is 3 out of 6 because we have 3 even numbers out of the total 6 in the sample space. So this is an example of classical or theoretical probability. When we look at the entire sample space, what do we have that is possible? And then also looking at the event that we want and how many outcomes are in the event. Classical or theoretical probability, the words are used interchangeably. This is usually what you see with gambling, when you're playing pretty much any kind of game of chance. Cards, dice, coin flips, these are generally classical probability problems. Empirical probability, instead of using the sample space, because we may not know the sample space, empirical probability uses actual experiences or past data to determine the likelihood of outcomes. And the formula for empirical probability, the probability of an event, is going to be the frequency of occurrences in the event. How many times did that event occur already? And we're going to divide that by the total number of trials or instances. So an example for this empirical probability would be going back to when we were actually flipping the coins in the previous part 1 video, where we were flipping coins and determining outcomes. The number of heads over 10 total flips, would be the probability for that coin flip. So probability of a head, number of heads out of 10. This is an example of an empirical probability. And we can take pretty much any theoretical probability and look at it empirically by just collecting the data. Flip the coin, roll the die, draw the card, collect the data, and then look at how many times you got what you wanted divided by how many total times you did the experiment. Now, it may not be the best way to talk about probability for those types of experiments, but we do have instances of empirical probability that are necessary, where we don't know all of the possible outcomes in the sample space, or the sample space is just so large that it'll be extremely difficult to calculate how many items are in it, especially if we're dealing with people. One example would be, what is the probability of a person selected at random who is left-handed? There's no good theoretical probability construct to determine left-handedness. So we rely on empirical probability. How many total left-handed people do we have out of this group? How many total people are in the group? And that would be our empirical probability, that ratio between the two of them. Subjective probability is one that we will not be using in this class. We most definitely will use classical. We most definitely will use empirical. But there is a third one called subjective. Subjective probability uses educated guesses, estimates, and opinions. You might be able to form a subjective probability of the likelihood you get struck by lightning. That's all going to depend on where you live and how many thunderstorms you have in that area and whether you're planning on being outside in the middle of a thunderstorm. So that's one example of a subjective probability, that you'd have to be able to estimate things, to use some guesswork. You can still pull in some numerical information, but subjective probabilities are very nebulous, hard to follow. So we tend not to use those very much. Regarding the coin flips, classical probability for flipping one dime and getting ahead, we'll add that in there, is 1 out of 2. The empirical probability for flipping the dime, you should see your own data. So what was the empirical probability you got for flipping your dime and landing on a head? Why are they different? Well, they're different because one of them, the classical probability, is relying on a sample space, the structure of the probability experiment. But the empirical probability is relying on past experiences, the data you collected. The probabilities are related. We're going to talk about that in a little bit. So this wraps up a lot of our definitions in the first section. We'll have a few more coming up in the continuation of this lesson, but what I would like for you to do is take a moment on the next page and try these 3 problems on foundations of probability. See if you can figure them out on your own, and then start part 3 and we'll work through them together.